and this is due to von Mises. Okay. So for part B, right, right, we are going to apply maximum shear stress. Okay, maximum shear stress criteria. Okay. So the maximum shear stress criteria is you have tau max, right, is equal to stress U divided by 2, right? So stress U divided by 2 is equal to U is 42 times 10 to the power 3 divided by 2 is equal to 21 times 10 to the power 3 psi. Okay. So we know that stress A and B are not equal to 0. Okay, and this is from 3D mole circle. Right, the mole circle is still the same. Right, the mole circle is still the same. Let me copy the mole circle again. Okay, the mole circle, the stress state mole circle is still the same, regardless of the criteria you use. Right. Why? You know what? Let me do this in another page. Okay. So B, we are going to apply from Mises, no, Tresca, sorry, maximum shear stress criteria. The mole circle is still the same, right? The stress state is still the same. So like what we learned on Tuesday for this week, right? We have to construct the 3D mole circle. Then why we have to construct 3D mole circle? Because Tresca has two conditions, right? So remember, you have tau max is equal to stress max over 2, where 1 of the principal stress is equal to what? 0. And I do apologize. Where, hold on. So tau max is equal to sigma max divided by 2, where 1 of the principal stress is equal to 0. If not, tau max is equal to a half, right? We did this before on Tuesday, right? So it has to satisfy where principal stresses are not equal to 0. So because the stress state is the same, right? Regardless of the criteria used, stress A and stress B are not equal to 0, right? So now we have to find stress A, okay, minus by stress B. And the same, we will let stress A be equal to stress average plus by radius minus by stress average minus by radius, like before, right? Because stress average or stress A, B is equal to stress average plus or minus radius. Okay. So what will happen is this is equal to 2R. Right? Stress A minus stress B is equal to 2R. Right? So from here, right? So we know that stress A, so tau max, so therefore tau max is equal to half absolute value multiplied by 2R, and tau max is equal to 21 times 10 to the power 3. So the radius is equal to 21 times 10 to the power 3. Okay, so from here, again, we apply the same formula, right? Knowing that the radius is equal to 21 times 10 to the power 3. So the shear XY, so this radius and this radius that we had in the previous example, or this radius, they're the same. Okay, or sorry, not the previous example. Now we are looking into this figure again. Okay. So now we again come back to here, right? So now this whole thing, now what we have done, our tau max is based on Tresca now. Okay. So again, this value is still the same. Sorry, I should not erase. The 16.933 is still the same. Okay. Only thing that changed is our radius now is what? 21 times 10 to the power 3. Okay. So the shear XY is equal to 21 times 10 to the power 3 squared minus by 16.977 times 10 to the power 3 squared. Okay. So this will be equal to, so 21 power 3 squared minus 16.977 power 3 squared, square root is 12.36. Okay, 12.36 times 10 to the power 3 psi. Okay, so therefore the torque in the y direction is equal to still the same formula, 12.36 times 10 to the power 3 multiplied by pi over 2 multiplied by 1.5 divided by 2. Okay. So this will be equal to, so 1.5 divided by 2 power 3 times by shift pi divided by 2 times by 12.36 power 3 is equal to 8.19 times 10 to the power 3 pound inch. Okay. So that's not all. We have to check. Okay. Okay. Hold on. We're not done yet. Okay. With Tresca, you need to check. Okay. So with Tresca, we have to check to ensure that sigma A and sigma B must be less than 42 times 10 to the power 3 psi. Okay, we must check. So sigma A and B is equal to minus is stress average plus or minus the radius, right? So the stress average we have is minus 16.977 times 10 to the power 3 plus or minus 21 times 10 to the power 3. Okay, so this is equal to 16.977 plus by 21, so it's minus 37.977 times 10 to the power 3 psi, and the other one is 4.023 times 10 to the power 3 psi. So it shows that we are within what? 42 psi. Okay, so what we realize is Tresca is more conservative. Tresca is more conservative because the torque Y allowed is equal to 8.19 times 10 to the power 3 pound-inch, right? So with Vomesis, right, the torque Y allowable is equal to 9.458 times 10 to the power 3 pound-inch. Okay. So in industry practice, okay, most of the time, right, when material is under torsional load, okay, only if it's just purely torsion, okay, Vomesis criteria is usually used, okay, usually, okay, if it's just torsional, right? But if you're unsure, go for the more conservative one, go for Tresca. Okay, right, I'm going to stop here now. Okay, so next week we're going to have our last lecture, and the last lecture will be on buckling. Now on buckling, I will not test you, but I'm required to teach you so that when you go to do 3E05, you know what's buckling. Okay, so that's all I have now. Thank you for your time and have a great long weekend and study hard.